Robotics is a fascinating field that combines aspects of mechanical engineering, electrical engineering, and computer science to create intelligent machines that can perform tasks autonomously. There are several key aspects to consider in robotics. Mechanical design. 1. Actuators and sensors. Choosing and designing the right actuators, motors, servos, and sensors, cameras, accelerometers, is crucial for the robot's functionality. 2. Structural integrity. Ensuring the physical structure of the robot is robust and can withstand the intended tasks. Electrical systems. 1. Power systems. Robots need a reliable power source, and designing efficient power systems is critical for their autonomy and functionality. 2. Control systems. Implementing electronic control systems to manage the robot's movements and responses. Programming and software. 1. Programming languages. Coding the robot's behavior using languages like C++, Python, or specialized languages for robotics. 2. Control algorithms. Implementing algorithms for navigation, path planning, and decision-making. Sensory feedback. 1. Computer vision. Enabling robots to interpret visual information from cameras for tasks like object recognition and navigation. 2. Sensor fusion. Integrating data from multiple sensors to create a more accurate perception of the environment. Autonomous systems. 1. Machine learning. Implementing machine learning algorithms for tasks like pattern recognition, learning from experience, and adapting to new situations. 2. AI integration. Developing artificial intelligence to enhance the robot's decision-making capabilities. Human-robot interaction. 1. User interface. Creating interfaces for humans to control and communicate with robots. 2. Safety systems. Implementing safety features to ensure robots can work alongside humans without causing harm. Communication. 1. Networking. Enabling communication between robots or between a robot and a central control system. 2. Wireless technologies. Implementing wireless communication for remote control or data transfer. Ethical and social considerations. 1. Ethical design. Addressing ethical concerns in robotics, such as privacy, security, and the impact on employment. 2. Human-centric design. Ensuring robots are designed with human well-being in mind. Testing and validation. 1. Simulation. Using simulations to test and validate the robot's performance before physical implementation. 2. Real-world testing. Conducting experiments and trials in real-world environments to ensure the robot can handle various conditions. Maintenance and upgrades. 1. Modularity. Designing robots with modular components for easier maintenance and upgrades. 2. Software updates. Providing mechanisms for updating the robot's software to improve functionality or address issues. These aspects collectively contribute to the development of advanced robotic systems, whether they're used in manufacturing, healthcare, exploration, or other fields. Robotics has a vast array of applications across various industries. Here are some notable ones. Manufacturing and automation. 1. Industrial robots, used for tasks like assembly, welding, painting, and packaging, improving efficiency and precision in manufacturing processes. Healthcare. 1. Surgical robots. Assist surgeons in performing minimally invasive surgeries with enhanced precision. 2. Rehabilitation robots. Aid in the recovery and rehabilitation of patients with mobility issues. Agriculture. 1. Robotic harvesting. Autonomous robots capable of harvesting crops, increasing efficiency in agriculture. Logistics and warehousing. 1. Autonomous vehicles. Robots and drones used for tasks such as inventory management, picking and packing, and delivery in warehouses and distribution centers. Space exploration. 1. Robotic rovers. Explore planetary surfaces in missions led by space agencies to gather data and perform experiments. Defense and security. 1. Unmanned aerial vehicles, UAVs. Drones used for surveillance, reconnaissance, and in some cases, combat operations. Education. 1. Educational robots. Used to teach programming, engineering, and problem-solving skills to students. Entertainment. 1. Robotic performers. Robots used in entertainment shows, theme parks, and other venues for interactive and engaging performances. Environmental monitoring. 1. Robotic sensors. Deployed in various environments to monitor pollution, climate, and wildlife. Home and personal assistance. 1. Domestic robots. Assist with household chores, elder care, and provide companionship. Search and rescue. 1. Unmanned ground and aerial vehicles, used in disaster-stricken areas to locate and rescue people. Education. 1. Educational robots, used in schools and universities to teach programming, engineering, and problem-solving skills. Retail. 1. Service robots. Assist customers in stores, guide them to products, and provide information. Telepresence. 1. Telepresence robots. Enable remote communication and interaction, allowing individuals to be present in a different location through a robot. Sports. 1. Robotic athletes, used for training purposes, assisting athletes in improving their performance. The applications of robotics continue to evolve as technology advances, and the integration of AI and machine learning further enhances the capabilities of robotic systems.